Hey guys, Papaya here. Today I'm going to be teaching you how to make an AR code that changes GameCube and Wii programming. Like it actually changes the programming instead of just setting a variable to a specific number. Normally people, I'm assuming, will write an AR code that will either test for something or that will always, like every frame, say, hey, I want the HP to be 77 or whatever, instead of whatever it would be. So it's always at 77, or setting the Y value, or just whatever. No, what we're going to be doing is a lot more complicated, where we're actually going to be changing programming inside of the game. So to do that, we have a ton of resources, and unfortunately 3 download links, 2 of which are required. The third one is just super helpful, and I would recommend it even if you don't end up doing this. And by the way, I'm making this video mainly based around someone named, I think, Space Penguin. I should have it written down, but I don't. He wanted to know how to uninvert the controls in Super Mario Sunshine when you are using the flood nozzle. And that is highly complicated. It's actually more complicated than everything I've ever done, but this has been a cool learning experience for me, so I'm glad that I'm actually trying it out. So anyways, the first download link, I'm going to do the downloads first. First download link is right here. It's a memory engine for Dolphin, and do I have it pulled up? I do. Cool. So it looks like that, and you can click on Open Memory Viewer right there, and it will open. Oops. So it just looks like this. We actually don't need that, I hope. But yeah, so it just looks like this. You can actually change the programming or the coding. So like this is FF, I can change it to 4.4, I can change it back to FF, I can do whatever I want. It will, if you don't know what you're doing, you're probably going to end up crashing the game or doing absolutely nothing. But anyways, so it's super helpful. It's helpful to see like just a ton of different things. Like I would just highly recommend that one. The other 2 are for ASM WeRD. I'll explain that in a moment, and that'll be the second download link. And the third is an experimental version of Dolphin that is over a year old. So it's not the current stable build, and it's not the currently newest Dolphin experimental version. And I will get into why we need not just this specific one. You could probably have a bunch of different ones, but this specific one will work. It's the one that I use, and so I know that it'll work. Alright, and with that, the rest of these, so this next one is going to be, it's not a download link. We're done with those. We've got the PowerPC instruction set, which takes you right here. Sorry, I should explain this. So this is just a bunch of different resources for getting into it, and if this doesn't apply to you, then that's fine. If this is the only code you're going to make, then that's fine. But this is just incredibly helpful, especially this link right here, the PowerPC instruction set. This unfortunately has been removed, so yeah, it just doesn't go anywhere. It's a 404 page. But this page, it won't look like this. It'll look like, we'll go 2 backwards. Did I go 2 backwards? No, only 1. Basically, it lets you search. It's basically your guidebook for the language that the GameCube and Wii games are all programmed in. Not necessarily programmed in, but what we can change them in. And so we're going to be needing to use this if we don't know what an instruction is. I'm going to be explaining all the instructions that we're going to need, or at least that I'm going to need, and if any of them aren't listed, or if I don't list any of the ones that you need to know, or if you have questions on them, then just go here. Next, we have this guide to AR codes and programming. We've got, this is just basic programming. If you don't know basic programming, you can read this section. I would recommend at least this hexadecimal section right here before this B, because hexadecimal is what we're going to be using to write our action replay codes. So I need to explain this. Assembly is, okay, so computers can only store numbers they can't store letters. And in assembly here, let me open up ASMWRD really fast. Where is it? I guess I minimized it. So this is an instruction. So this says MULLI space R1 comma space R1 comma space 12. I'm not going to get into this because it's not super important for what we're doing right now. I will explain a lot of the codes later, like I said, or a lot of the instructions later. But basically, the computer can't do any of this. There's only a couple numbers in there, and the rest are just words. So what this ASMWRD converter does, let me write a different code because this is just going to change it to the same thing. Basically, we're going to do LWZ R3 0 R9. There we go. That's an instruction. So what this does, it was probably hard for you to see, unfortunately, but it changes this thing. So we ignore that part, and we ignore the 0 because we only have 1. So like here, let me do this again just to explain this. So this has to do with how long the code is. That's how many lines there are in our code on this side. So if I just like copy this, paste it, and then change this to register 3, it's going to change it to 2 lines, even though we only have 2 lines right here. Okay, sorry, we need to do this again. Let's do register 7 this time. Okay, now even though we have 3 lines, it's only on 2 of these lines. So that's what that 2 means. That's all that is. And then this just, I don't understand it, but you don't need it. So anyways, this will convert it from, what I'm getting at is this will convert our assembly into hexadecimal assembly, which our code, which we can actually put into our code. So let's see. So that's hexadecimal, and that's why we need to know hexadecimal. So I would recommend reading that. It's also helpful because this link, is also helpful because it tells us all of the action replay code instructions and all of the conditionals below it. It's not a complete guide, unfortunately, and this is like 5 years or 6 years since he's actually edited it. So unfortunately, it's probably never going to be completely done, but it's done enough that we can get what we need out of it. So next we have a hex calculator, which can just be super helpful, especially when you're dealing with pointers. I'll get into pointers later. For now, you just need to know that they're how the program knows where to look for specific variables. Each variable, I'll just explain it now. Each variable is stored at a specific location in memory. So like if we open our cheat manager, I'm assuming you know how to do AR codes a little bit already, but I'm going to go through it anyways. So we've got the address, which is right here. It's going to add 80 to the address at the beginning, so it's going to be 8018777E. Because it's 02, it's going to write a half word or the right 4 digits that are over here, and then anything on the left half of it is just going to duplicate it for the next that many half words. So if I have a 1 here, then it will write 07E2 to 777E, which will change 7E and 7F, and then it'll also do it to 80 and 81, or 880, nope, 80 and 81, my bad. I'm confusing myself and probably confusing you, and I'm sorry about that. But anyway, so that's just kind of the basics of an AR code. And so the pointer part is right there. Action replay codes work differently than assembly, but we're going to be using action replay codes to write assembly code into the game. So anyways, this is helpful for finding pointers. And then finally we have a float converter, which just converts things from floats into non-floats, and vice versa. non-floats into floats. Alright, so next we are going to, I'm going to minimize that. Next I'm going to teach you how to get the Dolphin debug mode. Dolphin debug mode is highly needed. Basically what you do, you right click, drag, create shortcut here, you right click and wait for it to be really slow. You click on properties, you click on shortcut, and at the very end of the line you hit space -D. You'd apply and you hit OK. And now when we open this, it's not going to look like how you're used to Dolphin looking. It's going to have all this stuff over here. Our games are over here. It's going to have the normal stuff right here, but then it's got stuff to the left, and then just under that it's got other stuff, and even over here it's got other stuff, like up here. So when you open it, the first thing you're going to want to do is you're going to want to add registers and breakpoints. So that's under View. Registers need to be checked and breakpoints need to be checked. You can also do memory if you want. It might be checked already. I don't know. So let me get into why we need, here I'm going to close this. You keep yours open, but I've already got mine open. My recording will mess up if I close it, or if I open a new Dolphin, so I unfortunately can't do that. So the reason we need this specific version of Dolphin, or a version like it, is two things. One, in the newest experimental version, they have removed a feature, which I'm kind of mad about, that lets you test for, okay, so let me just read what's in here. Value to match against can be hex, which starts with 0x, octal, which starts with 0, or decimal. Leave blank, this is the important part, leave blank to filter each result against its own previous value. So if we're testing for the x value, we don't know what the x value starts at. We don't know if it's greater than 0 or less than 0, because we don't know if it's negative or positive. We don't know if it's like 10,000 or 5. You know, we don't know anything about it. So we can leave it blank in this version of Dolphin. We can't leave it blank in the latest experimental version, which is super frustrating. If we leave it blank, then it makes it a lot easier to find variables. In this case, since we don't know what the variables start at, we need this so much. But why we can't use just the latest stable build is because of something in breakpoints. This memory breakpoint right here, plus MBP. It does not have this feature, which is, again, just absolutely needed. And I need to add a note. If you add a memory breakpoint and the console instantly crashes, then there's unfortunately nothing that you can do to make this action replay code. I'm sorry, there's just nothing if it crashes. I don't know how to fix that. I don't know if there is a way to fix that. It's just can't do it, because it's just going to crash and we're not going to be able to find what we need to find. Okay. Alright, so our next step is to find the direction, the variable for the direction that we're going to be changing. So in Pirate Penguin's case, you're going to want to find the Y direction, so the up and down direction, because that's what you want to change. You don't, as far as I understand, you don't want to make it so that when you hold left, he goes and turns to the right. That sounds weird. So yeah, just test for the up and down direction. I've already done that for mine, and it's about right there. If I pause, I can actually see that. Yeah, okay, so this is where it stores it, and this is right there. That is where it picks it up from. And the reason that I know where this is I used the memory breakpoint. So all you need to do is add the memory breakpoint and type in your thing. This is not right, however, that's the pointer to it. what I can do is I can, because I don't remember where it is. It's taken so many days for me to make this AR code, or this video. It's insane how much I didn't realize how hard it would be. So register 28. So, oh, I forgot to explain this. I've done this multiple takes even. So here we have a line of code, and I'm going to explain what this does. LFS means load float shifted. So it's going to load the float. It's going to load the left half of the float on the left. And it's going to load from one of these, and we'll see which one we're going to load into, not from, into in a second. So it's going to put a float into these floating point registers. So these are floating point registers. These are your somewhat normal registers. The top three are a little different than, that's not three. The top three are a little bit different from them. So anyways, we're going to put something into the floating point registers. Oh, and I should explain, registers are the things that let you compare numbers easier. So we have an action replay code that lets us compare an address, the value at an address, to a number. Registers can do that. Registers can also compare a value in two different pointers to each other. So I could load the HP and I could load the magic, not in this game, but I could load the magic, and I could compare them together, and if they were equal I could make a rare enemy spawn, or just something like that. Whereas with action replay codes, you can't really do that. Yeah, we're gonna make it go to a different part of memory and then run code there, and then we're gonna have it come back. So let me explain what this does now. Load float shifted, so that means we're gonna load a float into the left half of this float. Not this side, but this side. Actually, it's gonna do both. If it's LFD, then it's gonna be, I think, the left half of this one. It might be the right half of this one. I don't remember. But it's one of the two, and I think I actually have one. Yeah, right there. So we'll be able to see that pretty shortly. Anyways, so it's going to load a float into floating point register from the pointer at register 28. So if we look at that, register 28, 80191128, I'm going to copy that, and I'm going to put that into my Dolphin memory engine. Again, this is the one that isn't needed, but it's so helpful to have. So this is where register 28 is stored. However, because of this number right here, this 0x0038, we're actually going to add 38 right there. So 2 plus 3 is 5, and 8 plus 8 is 16. Since this is written in hexadecimal, it would actually be 60. So this is my float, right there, that I'm affecting. However, this is the z-axis float. This is the x-axis float, and this is the y-axis float, right, from there to there. So you're going to want this one. You should have something similar where the x, y, and z rotations are, or rather, not rotations, direction. Those are slightly different terms. You're going to want the y, and it should be all together. So anyways, we're going to load this float into floating point register 0. So we're going to look at registers, we're going to hit step, and it is different, and I don't know why. It's just always different when it's in the register, so the register must work slightly differently, which might actually affect our code, and if it does, then I'm just not going to be able to help, unfortunately. We can almost invert them, but not quite, if that's the case. Anyways, so next it's going to store a word. So that means that it's going to take whatever's in register 0, and it's going to put it into the SP register, not into the SP register, but the pointer in the SP register. So this is the SP register. It's also called register 1. And basically the SP register is one of our 3 special ones. Let me explain the special ones that I know of. R2, the RTalk, I have no idea what it does. It's probably with like graphics or sound or I don't know what. Or maybe it's a second SP, I don't know. But anyways, register 0, I'm not quite sure what it's special for. Well, I know that it has some like slightly different instructions that you can do with it that are pretty cool, but we're not going to get into them. But you also can't, I can't remember what it is, if it's like you can't add register 0 to itself, or you can't load immediate shifted into register 0, you can only add into register 0. I can't remember what it is. So load immediate shifted is how you get, like, it's again the left half, so 802D is what my SP register would have. So at some point it probably had 802D, had load immediate shifted, register 1, 0x, 802D. To put it into this half. And I can probably show you something like that shortly. But anyways, yeah, so just register 0 can't do something like that. Register 1 is the SP register, and it is really important, and so I wouldn't recommend that you use it. It basically is how the game keeps track of just about everything. Like, it stores, it's basically a place for temporary variable storage. So anyways, then we have all the rest of these, which are just normal variable, or normal registers. So we've got load float shifted, so we're loading a float into float 0. We always do something either into or from the first one. So in this case, store word. It's going to store the contents of register 0, which is 8000 for me, into the SP registers pointer plus 44, not 44, but plus 44. Let me just check that, plus 44, C, and then B, C, D, E. Alright, so I'm going to change this to 1, 2, 3, 4, 5, 6, 7, 8. Just to show you. Normally you wouldn't want to do that, but if I hit step, it's going to change that because it's adding the 44 to the SP, and it's just storing that 8000 into that register, or into the place where I just said. Okay, next up we have a store word, register 31, so it's taking what's in register 31 and putting it into the pointer at SP, at the SP register, but it's adding 40 to it, so we can just subtract 4 from that. And we have this right here, and that should change to, actually to 4330. So we're going to hit step, and there we go. And then we're going to LFD, so that's load float, and then D is whatever half it is. I don't remember where exactly it is. It's going to put something into floating point register 3. It's going to be from the same pointer that we just put the thing at register 31. So we're actually going to get 4330 into this whatever, it's register 3, right? Yeah, register 3. So we're going to get that. So yeah. And it is, okay, so this is only the left half. It's only the left float is basically what it is. Okay. And then it's going to do some math. So it's going to subtract. So F sub is float subtract. S is again shifted. So it's going to put what it gets. So it's going to put the answer of this subtraction problem into floating point register 3. And it's going to subtract the contents of register 4 from the contents of register 3. So if, or floating point 3. So if floating point 3 had, let's just say 5 and 4 had 4, then 1 would get stored into floating point 3, except they're going to be floats. And since it's floats, it's going to be 0. So with this, I can actually tell that well, actually I can't tell that. But basically, now this is FMSUBS, so it's going to subtract multiple floats together, and I might actually be wrong with that. Let's actually go over to this, and then let's search for FSUBF, not FS. Let me just double check that that's where I want to search. Nope, that's not where I want to search. FSUBS. F subs. There we go. There we go. So we've got F of RT, so that's the one that we're gonna store it in. So we would type FSUBS. So here, let me go into our ASMWRD, which is gonna help us make our code. I'm gonna type in FSUBS space, and we would want our first register, our first floating point register, so it'd be F3 comma F3, so it's going to take FRB down here, this one right here. Let's do that. It's a glitch with ASM WRD converter. Anyway, so it's going to take this one and subtract it from that one, so F4, and they're going to be floats because they're float registers. So the FR means floating point register, and then the T is the target. It's the place that we're going to put it in. The A is just like the first variable, and the B is just the second variable. And then it'll describe it down here in case you don't know, because there are some really complicated ones that even I don't get. Like, I don't even get why they exist. They just don't make sense. Anyways, so let's get back to this. And then FMADDS is the same thing, except it's adding instead of subtracting. So it's going to add floating point 2, floating point 1, and floating point 0 into floating point 0. Now if we look up here, we have floating point 0 as our direction already. Oh, sorry, before I get into that, so what we want to do right now is we want to find the controls or the direction that it wants to change it by. So basically what we're doing is we're saying, hey, the player is holding forward and the game knows that. Let's make it so that instead of holding forward, they're holding backwards. So we need to multiply one of these floating points by -1. Okay, so now we want to, so this is where floating point 0 gets stored, or gets written to, where it gets overwritten, its contents get changed just before we're going to store it back into our place that we got it from. So I know that whatever one we want to change is either floating point 2, floating point 1, or floating point 0. And I don't know which one it is. But we're going to get into constructing the code. The only way for us to figure it out is to change it by -1. Change one of them by -1, and then just see how it happens. So, before I get into it, I want to say that when you're doing something like this, when you're changing instructions, the game will not update until you emulation load state, or until you reset. You can force it to change it by right-clicking and then doing replace instruction and then replacing the instruction. However, we're not going to do that. What we're going to do, so open up your WRD converter, and we're going to want to, okay, so we're going to want to take down this instruction. We can actually just right click and copy code line, and then we can paste it into here. And now we have this FM ADDS F0, F2, F1, F0. So now that we have that, we're going to hit enter. Sorry, we're going to put before it B 0x 017, and now this is where it's going to vary a little bit. So mine has a 1 right here. So we've done, okay, so basically what we're doing, this B means branch. So this is where we're writing the code that's going to say, hey, go to unused memory. From what I can tell, all games have unused memory towards the end, not at the very end, but pretty close to the end of memory. Memory goes from 8000 to 817F, and then the rest are Fs. So we've got branch 017, so this means it's going to keep the 8 the same. The 1 means it's going to add 1, so we're going to go to 817 because we're adding 7. And next, because this is just adding this to our current PC, we want to branch to 8175. So if this is a 0 right here, not a 1, then you would want to type a 5. If it's a 1, you want to type a 4. So I'm going to end up typing 4. And then just keep subtracting from it as long as it's a 1. And same thing with this digit. If it's 8010, then you're going to want 0164. And that's just going to make, or 5 or whatever it is. And that's just going to make it so that we don't go somewhere that we don't want to go. And overwrite random memory that I don't even know what it does. So then we type in 4 zeros, and then we're going to click on this right arrow. Now it's going to be a little hard for you to see on my screen, but basically you want to delete the top line that has to do with how these codes are instructed. Next we want to, or I don't know if I said instructed, but I meant constructed. If you have these 2 lines on the bottom, 6000 and then 0000, you want to delete them. Otherwise, you just want to delete the 0000. Just like with action replay codes, there's a glitch where if there isn't an extra line under it, it basically just deletes the bottom line of whatever code it is. So in this case, it's going to delete this one, and then this just says, hey, this is nothing. So, and action replay codes do it automatically now. They didn't before, but they do now. So we're just going to want to delete this 0, and we want to delete this 6000. If this is ever not 6000, then you don't want to delete that. All we're interested is right there and right there. For now, we're interested with this one, so we're going to copy it, and we are going to, so we're going to inject our code right here, and we've already copied this instruction, which is the last instruction that edits floating point 0 before we store it. I'm saying that again just to make sure that you have the right line. It might not necessarily be the one right above where it's going to store it. So we're going to right click and we're going to replace instruction. We're going to type in 0x and then we're going to Control V or paste it in. Now it says that I have an invalid text input. That's because I have a space at the end. Now that I've deleted that, it says it's going to branch to 817574D4. So let's click on that, and there. Now you do not want to hit play, because what this will do is this has actually changed the instruction. So now it's going to branch to this, and this is just nothing. So it's going to execute a lot of nothing and crash. I'm going to show PC just so that I can go back to this. Next, what we're going to want to do is, so this is going to be our last line of code that we add before we branch back. And we won't be able to branch back until we've found how many addresses we have to go. So we hit enter in between those. What we want to do now, so this is where we're going to, right here. I'm going to put a breakpoint right there so that it's easier to see. we want to put this address into any register, but not just any register. We need to find a register that it won't matter if it changes. So let's go back, let's show PC. So the way that we're going to do this is we're going to look at this left side. And this could easily take a while. I'm sorry, but this could easily take a while. We're going to look at this left side, and I'm actually going to max screen this now. And we're going to say, hey, where do we load the next variable on the left? So here, let me do this to make it easier. So this is a function that I have named the in-game timer because that's what it does. It increments the in-game timer whenever it needs to. So right here actually, ignore this. This is just a complicated way to say, hey, go back to where you were before you branched here. And it's only if it's not equal to, that's the any part, and then the BLR part is, hey, you're gonna go back. So right here, we're gonna load something into register 3. So this is awesome because this is what we're looking for. We want something that loads into register 3, or we want something that would subtract immediate, so it's going to subtract a register and a number, a number from whatever's in this register and put it into register 4. So we could use either of these right here. We could either use register 3 and then have the last instruction be this load immediate shifted so that we don't cause errors, or we could have it be right here and use register 4. But we can't use register 4 afterwards. So if I were to try it right here, well, we need something, a specific something in register 4. We just had these two variables, or these two instructions that make register 4 become whatever this is, 8013 something 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 something, because it's subtracting it. So we don't want that. We don't want to crash, and so we wouldn't be able to use register 4 if we started it from right here. We could, however, use register 0. But right here, if we were doing it here, we couldn't use register 3 because this is what we're doing. You also can't do it if it's going to store something from the register. So if this was STW, if it was store word from register 4, we can't use register 4. We can't use anything on the line, in fact, any of the registers on that line. So let's delete this and go back to here, and let's start looking. And I actually know which two I'm already going to use, because, okay, so before we look for that, we're also going to need an empty floating point, like a floating point register that isn't going to be used. You can find them in any order as long as you make sure to write them down. I usually just like hit enter a couple times and then F whatever number and then register whatever number and then just fill it in from there. In my case, so we can't use floating point 0 because so because we're using floating point 2 and 1 and 0 for this instruction, we can't use any of those at all. Oops, that's not right. So I can't use 0, 1, or 2. So I can skip this one, this one, this one, and this one, and that one, and that one, because all of those start with that. However, now we have FADDS, so this adds floats together. It's going to add floating point 2 and floating point 1 and store it into floating point 4. And that's what we want. So I'm going to delete that and put F4 because we want the floating point register 4. And the next one is going to be the register. So we're going to look for our normal register, non-floating point register. And I do know what this is already. I've done this, but basically I know that I have to go a fair amount down because, like, see, all of these are floats. They might be hard for you to see. In fact, let me see if I can. I swear I keep doing this. Options, font. Let's make this like 16. There we go. That's probably pretty easy for you to see now. But yes, we have all of these like float 2, float 0. You're also going to want to be careful about branching. So like if we were putting our code right here, or here, let me find a better one. Right here. Okay, so this is actually where my register 3 is going to be. So let's just say that it was comparing register 3 to the number 10, and let's just say that it had the number 11 in it. Okay, so it would say register 10 is greater than 11. If it was 10, then it would say it's equal to. If it's 9 or less, then it would be less than. And basically then you can have something like this. Branch, so this is BNE minus, so branch not equal to. So it's gonna branch if it's not equal, if the compare that it just did is not equal to each other. So in this case, if it was register 3, which had 10, and we compared it to the number 11, they're not equal, so we would actually branch. This minus sign just means it's something that you have to add to conditionals, either a minus or a plus. And it basically just tells the game, hey, this is going to happen more often, or this is going to happen less often. Like, we're not expecting this to happen very often. For instance, if you're checking the game for how much health you have, to see if you should cause the game over screen to start, you're going to say branch if equal to 0 or branch if less than 1, and then a minus sign because you're not expecting the player to be dead on most frames. You're not expecting to get this condition. Anyways, so right here we have this branch, which is going to branch us all the way down from here, just to keep track of it a little easier, to right there. So basically, because we branch, we don't know if this register 3 is also going to be used down here where it's going to branch, because it's going to skip everything in here if it's not equal to. And we don't want that. So, well, we don't want to mess things up. So we have to look through and see, okay, so register 3, there's nothing on the right side with register 3. If there's anything on the right side with register 3 before now, the game will crash. And so we can just click up, and I'm just kind of glancing through and I'm seeing none of these are using it, so we can use register 3. But I have to be careful. I have to check, I have to follow a branch, and I have to check, is register 3 also usable if it gets to here? And yes, it is, because it loads something into register 3. So I can use register 3, and I can use floating point register 4. So let me put that there. Next, we're going to go back. So it's actually in reverse order. So you're gonna, so these are my first 2 breakpoints. These are the last 2 breakpoints that I had. I'm actually gonna delete those because we don't care about them. And we're gonna go back here just for a little bit later. So next, now that we know this, we're gonna say, so we want to load a specific place into register 3. So let me do that, because that is easier for me. So let's follow this branch. We want to load right there into register 3. So what we're going to do is I'm going to take these first 4 numbers, which should be the same for everyone, hopefully. If not, then just whatever these first 4 numbers of the address are. So we're going to LIS R3, because that's our normal register. We're going to put a comma, space, 0x, and in my case, 8175. You're going to do whatever instruction, or not instruction, whatever address the first half is for you. Okay, so this next part is a little complicated. We have 74D0. If I, oh, that's why, 75, there we go. So if I do like, so let's just say that I ended up right here. Anywhere past the right half being 7FFF, you're actually going to want 8176. And the reason for that is, here, let me just show you. So we're going to delete both of these. I know that I need floating point 4, and just to make sure that I don't forget it, I'm going to put that right there. If I do this, it should, yep, it builds it. And then, so our next instruction is we're going to add something to register 3. So ADDI, we're adding an integer and register 3 together. So R3, we're going to sort into R3, 0x, and the 0x is important for both of those. However, if I have this 84D4, and I click the right arrow, it gives me an error, and it doesn't build it. If I change this to a 7, then it does. So basically what you're going to want to do, and I'll do it for this just to show you. So we're going to copy, so right click, copy address. We're going to go to, that's not what I meant to open, that's embarrassing. We're going to go to our hex calculator. This is where it's super helpful. So we're going to do minus, sorry, we're going to have it be right here. 81760000. So this is what we have in our register if it's 8000 or greater on the right half. Then we're going to put 8176 into that because it's one more than 8175. And then we're going to subtract our pointer from it, and we're going to see how much we need to subtract from it. And this is going to be 7B2C. We need the 0x in there. You could also write 31532 and not put the 0x, but I prefer this because it deals with pointers. So then we would want that. So we're going to, instead of ADDI, it's going to be SUBI, that. And actually, we can save a line of code by doing LFS F4, comma, that, and then in parentheses R3. So now what this is going to do is it's going to load floating point, it's going to load 8176 in this case. We would want 6 into register 3, and then it would load the float. Oh, sorry, my bad. We need a minus sign right there because we're subtracting it. So basically what we're doing is we're saying, as I explained earlier, we're saying, hey, this is putting a number into register 3 that is the pointer. So we're loading something into floating point 4 from our register that holds our pointer, except we're subtracting 7B2C from whatever that pointer is. We're not actually changing the register. We're not actually changing the value in the register. We're just saying, hey, it's this many addresses, in this case before, because we're subtracting it, and we're going to load it from there. But yeah, so we're going to load whatever thing, and we're going to put something in this address in a minute. But we're going to, well, yeah, we're going to put whatever is in this pointer into floating point 4, and then we're going to do something with that. And I'm actually going to keep, well, no, I'm going to show the other way. If you have 8175, then you would just want to, and let me go back to where I was. Oops, that's not where I was. Show PC, follow branch. So I want 74D0. So instead, I'm going to do the exact same thing, except I'm going to delete this part. I'm going to put 0x because we're adding. So I'm at 8175, and then we're adding something to it. 0x 74D0, and it doesn't have to be capital, but I like to have them be capital. I'm used to it. So now it's going to, instead of loading it from wherever we were loading from, we're going to load it from right before. I was just showing what to do if it's greater than 7FFF. The right half of this thing, which mine isn't. So anyways, now that we have that, we're gonna load something into floating point 4, and we're gonna write that in a moment. Next, this is the line that's going to vary. So you can actually type in NOP. So that just basically means this isn't an instruction. This is not an instruction. We're not gonna do anything. And I think I'm going to do this just for testing. We're going to right click and replace the instruction there. And then we have this. So this is where we're going to change. So basically we're going to put the float of -1 into floating point 4, which is not just -1. It's more complicated. I think I remember what it is. But anyways, so in this instruction, we're going to multiply one of these two floating point registers by this -1. We don't do 0 because 0 is the one that's going to get stored, or sorry, it's not the one that's going to get stored. It's the one that's going to, it's the one that has the, if we go back to our PC, it's the one that got, like from this address, it's the one that got our, variable. It has our current direction in it. And so if we multiply that by -1, then we're gonna, every frame that we're trying to change it, we're gonna change it by -1. We're gonna multiply it by -1. So in one case you would basically like rotate randomly, like it's not gonna function. So we want to just multiply either floating point 1 or floating point 2. And because I don't know which one, like I said, we're going to test for it. So the last thing we have is -0x1. That's always going to be the same for everyone. But this is where it becomes a little bit of a challenge. So we want to take this number, we're gonna put that there. We're going to go to our calculator and then click on that so that it actually shows up. So I'm gonna put this right here. Oh no, sorry, we want. Okay, so it's complicated. So basically, because we're going to be subtracting from our current PC, the place that we're going to do the next instruction, because we're subtracting from that, we want to know exactly where to go. And there's a trick for figuring out how. So you want to take your the place that you want to go. So I'm going to, in this case, mine is right there, so I'm going to copy the address. I'm going to paste it into right there so that I have it stored. And then we're going to, see, I'm kind of forgetting how to do this. So we have our hex calculator open, we have our ISMWRD open. We're going to copy the last instruction that we're going to do, the place where it's going to be. So we're branching to right here. That's the first instruction that we're going to do when we're here. This is what we've used to actually get to where we are. So we have 1, 2, 3, 4, 5, and the fifth one is going to be our branch function. So 1, 2, 3, 4, 5. So this is where our branch function is, or our branch instruction is going to go, not function. I keep saying function, that's not right. So I'm going to right click and copy address, and I'm going to paste it into the second one, the one on the right. So I've already done this, but I'm going to show you. I'm going to show PC. I'm going to right click, copy address. I usually paste it in there just to have it stored somewhere. That's not going to like jump me around in memory, because this one will actually put you in somewhere else in memory. This one lets you filter out symbols if you want specific types of, like, specific names of symbols. But anyway, so I've copied this address. I'm going to paste it in there. We're going to calculate, and we get this number, and that doesn't seem right. So I'm going to just double check this I'm going to follow branch, and it was the E4. I remember that. We're going to replace instruction 0x. Oh, duh. We're going to Control V, do that. So I'm going to build mine right now, and then I'm just going to copy this. Oh, this is right. This is right. Okay. Yeah, okay. That's right. Okay. Yeah, okay. Cool. I'm glad that I was able to figure that out. So yeah, we now have our code. So this is gonna, here, let me just show you. Replace instruction 0x Control V, because I copied this. This is the actual line that we care about. And we're gonna branch to 8001. So this starts with 8001. 74D8, it ends with 74D8. So we're actually gonna branch to the right place. If I hit OK and follow branch, now we see we're right where I want to be. However, we're not quite done. There's two things that we need to add to our code, one of which being this line, and the other thing being the thing that we're going to put right here. So we're going to copy this address right now, and we're just going to start writing our code now. So we're going to add a new code. As you can see, I've tried this multiple times already. Invert controls is just what I'm going to call them. You can call it whatever. So we're going to paste in our address, except we're going to change the first two to 05. So what that means, so normally a 04 would say, hey, I'm going to write everything right there. I'm going to write everything into this address except put 80 at the beginning. And I'm going to write it everything right there. Everything that's right here. 05 makes it so that instead of 80, it's 81. It just adds 1 to the left two parts of the address. So it's going to be in deep memory. It's going to be, I call it deep memory, that's probably not what it's called. 7574D0, so that's our instruction right before. And then we're going to put something there. What are we going to put? We're going to, oh, not this, we want that. So right here we have our floating point converter. We want to put -1 into here. You don't actually have to do this because I'm doing this for you. -1, the float of -1 will always be this, which is BF800000. So you're just going to want to write that down, and if you want you can copy it. Doesn't really matter, but we're going to put that right there. So now, and we're not going to hit play yet, but now we have this, so we're going to write this into this address. Okay, next we're going to, actually we're going to hit save and apply. We're going to follow this branch, and we're going to right click on the branch instruction that we have earlier, and we're going to copy hex, and we're going to so we have our hex calculator open, we have our ISMWRD open. We're going to copy the last instruction that we're going to do, the place where it's going to be. So we're branching to right here. That's the first instruction that we're going to do when we're here. This is what we've used to actually get to where we are. So we have 1, 2, 3, 4, 5, and the fifth one is going to be our branch function. So 1, 2, 3, 4, 5. So this is where our branch function is, or our branch instruction is going to go, not function. I keep saying function, that's not right. So I'm going to right click and copy address, and I'm going to paste it into the second one, the one on the right. So I've already done this, but I'm going to show you. I'm going to show PC. I'm going to right click, copy address. I usually paste it in there just to have it stored somewhere. That's not gonna like jump me around in memory, because this one will actually put you in somewhere else in memory. This one lets you filter out symbols if you want specific types of, like, specific names of symbols. But anyway, so I've copied this address. I'm going to paste it in there. We're going to calculate, and we get this number, and that doesn't seem right. So I'm going to just double check this. I'm going to follow branch, and it was the E4. I remember that. We're going to replace instruction 0x. Oh, duh. We're going to Control V, do that. So I'm going to build mine right now, and then I'm just going to copy this. Oh, this is right. This is right. Okay. Yeah, okay. That's right. Okay. Yeah, okay. Cool. I'm glad that I was able to figure that out. So yeah, we now have our code. So this is gonna, here, let me just show you. Replace instruction 0x Control V, because I copied this. This is the actual line that we care about. And we're gonna branch to 8001. So this starts with 8001. 74D8, it ends with 74D8. So we're actually gonna branch to the right place. If I hit OK and follow branch, now we see we're right where I want to be. However, we're not quite done. There's two things that we need to add to our code, one of which being this line, and the other thing being the thing that we're going to put right here. So we're going to copy this address right now, and we're just going to start writing our code now. So we're going to add a new code. As you can see, I've tried this multiple times already. Invert controls is just what I'm going to call them. You can call it whatever. So we're going to paste in our address, except we're going to change the first two to 05. So what that means, so normally a 04 would say, hey, I'm going to write everything right there. I'm going to write everything into this address except put 80 at the beginning. And I'm going to write it everything right there. Everything that's right here. 05 makes it so that instead of 80, it's 81. It just adds 1 to the left two parts of the address. So it's going to be in deep memory. It's going to be, I call it deep memory, that's probably not what it's called. 7574D0, so that's our instruction right before. And then we're going to put something there. What are we going to put? We're going to, oh, not this, we want that. So right here we have our floating point converter. We want to put -1 into here. You don't actually have to do this because I'm doing this for you. -1, the float of -1 will always be this, which is BF800000. So you're just going to want to write that down, and if you want you can copy it. Doesn't really matter, but we're going to put that right there. So now, and we're not going to hit play yet, but now we have this, so we're going to write this into this address. Okay, next we're going to, actually we're going to hit save and apply. We're going to follow this branch, and we're going to right click on the branch instruction that we have earlier, and we're going to copy hex, and we're going to double click, and then we're going to, well, hang on. We're gonna, so now that we're done with this, we're gonna paste that into that. We're gonna copy the address. Oh, we can't do that, dang it. We're gonna paste one of them. We're gonna paste this one right there, and then we're gonna copy the address. You will have to change this back, by the way, when you do your code, but we're gonna put this right there and then change this to a 04 at the end. And then we're going to space, and then we're going to cut that, and we're going to paste it there. So now it's going to say, hey, instead of whatever you were doing right here, we're going to branch instead. We're going to do our instruction right here instead. Let me just change that back. It should be 8 followed by 7 zeros. So anyways, then we can save and make sure you hit apply a ton of times. to make sure that it applies. Next, we are going to do our final line of code. So we want to that's really cool. So it's FMUL is what we're going to want, not FMS. That's not even an instruction. FMUL floating point 4 comma floating point, or not, sorry, not floating point 4, floating point, and we're going to choose one of our two that we don't know what it is. So in this case, I'm going to choose the first one. Floating point 2, it's going to store it into 2. Floating point 4, floating point 2. I clicked on 3 on accident. So now it's going to multiply our -1 float, our float of -1, by whatever is in floating point 2, and it's going to store it in floating point 2, and then it's going to add all these things together. One of these is the rate of change, and we just don't know which one. It might actually be both of them, in which case we would have to change our code a little bit. So now we have everything that we need. We can delete this top line because we aren't using it anymore. We have it already written in our code. And we're going to right click, and hopefully it builds right. If it doesn't, check the syntax. Make sure that there's a comma after every single one of these things. Don't put a comma between this in parentheses register 3 and this second half of our pointer. Make sure that there isn't any extra stuff. I think you can have like a space and it's fine. Yeah, it's fine. It didn't have an error. So yeah, anyways, so then like I mentioned earlier, we're going to delete the top line C200, and in my case 0000 ends with a 3, so we can delete that, and we're going to delete this 0. Next we're going to double click on our thing. We're going to well, hang on, before we do that, we're going to follow our branch, and we're going to copy this address. We're going to then double click on our thing, paste it into here, change the last 2 digits to 05, and we're going to start making the game write our code. Every frame, it's going to write our code into this unused memory, so we're going to be using it. So I'm going to double click and Control X, and I'm holding Control still, click Control V. Now what I like to do with this part is I like to copy this first part, so Control C, and then I'm going to click at the end, I'm going to hit Enter, and then I'm going to count how many instructions I have left. So in this case 1, 2, 3, 4, so it does 2 per line, by the way, 2 instructions per line. So Control V, so that's 1, Enter, Control V, that's 2, 3, 4, so that's how many we have left. And then so if you read the hexadecimal thing, then you will be able to figure this out on your own. If not, I will explain it right now. Basically, we want to write the right things, because if I just do D4, then we're just going to have multiple things writing to the same place, and it's just going to basically be whatever one writes to it last. So we don't want that. We want to increase this by 4 every time, this last number by 4. So in this case, it would be D8, then DC, because it's hexadecimal. 8 plus 4 is 12, and 12 in hexadecimal is C. And then we're going to add 4, and because 12 plus 4 is 16, we're going to carry it because we're in base 16, so we're going to end with a 0, and we're going to get D plus 1, or 13 plus 1, which is 14, or E. So now I have E0, and then we're going to do E4 at the end. We want to put a space at the end of all of those, and then we're just going to hold Control, double click on the next instruction, X, and I'm still holding Control, click V, I'm hitting B, double click X because I'm still holding Control, and just continuously hold Control and copy all of these into there. Save, apply, and then, sorry, I'm kind of talking a little loud. And then we're going to want to, so we're going to want to keep this breakpoint. I would suggest putting a breakpoint at least at the branch so that you can see when it makes it there, or sorry, not there. right here. So I'm gonna breakpoints clear, so that gets rid of all my breakpoints, and then I'm gonna put a thing right there. And then we're going to emulation load state slot 1. So I'm gonna click right there and hit play, and as you can see, it's not going to happen until I actually throw it. So now we have our branch function. We're going to hit step, or not our function, our branch thing. So we hit step and we come to right here. So this is our first line that we wrote. This is actually the, if you had the float of -1, but you were reading it as an instruction, this is what it would be, stmw, don't know what that means, from register 28, or yeah, it's just going to store something, I don't understand, but we're not going to execute that. So we're going to load immediate shifted into register 3, that looked different, but that's okay. So 8175, and then we get our BFF0, which is not what we put in, but again, so we put BF80. Did I make that mistake? Is that me? That's not what I'm looking for. Did I make that mistake? That might be me. I might have done BFF0. Nope, I did BF80, so I don't know what it's doing. But anyways, it's hopefully it's -1. And then we're gonna FMUL float 4 and float 2 and put it into float 2. So now it's BFC99999. And then we're going to add them together into floating point 0. And that didn't change. Why didn't that change? Oh, it's not float multiple. It's not adding multiple things. It's adding float 2 and float 1 and multiplying it by float 0 and storing it into float 2. Okay, that's what's going on, I think. Then we're going to step, and we've got it. So now we can hit play, and as you can see, okay, so now I'm going to hold forward, and it's going left. I hit, yeah, okay. So this isn't working. Actually, it is working. Whoa! Sort of. It's sort of working. It's sort of working. It's rotating it. So, yeah, so basically, oh yeah, that's why. The reason it's only rotating it is because I'm actually doing the z-axis, not the y-axis. So this might actually work for you. I would have to do another line of code that would end up making it right. But anyways, let's get into what happens if that wasn't right. So I'm going to go back here, not here, 7, there we go. But I'm going to go back here, and let's just say that this didn't work. Then all we're going to do is we're going to choose our other one, F1, and we're going to change that, and we're going to change both of our float 2 into float 1, in my case. And since it is the 1, 2, 3, so it's the third one, we can, so I like to copy this and save a backup, but I have the video, so I already have the backup. I'm going to delete these two, and then I'm going to just do this, and I'm going to copy this, and I'm going to right click on the one that it was. So in this case it's right here, it's this FMUL. We're going to replace instruction 0x, and then we're going to control V, delete the last one, hit OK, and then hit play. So now that's actually done that, and we're going to do this. Yeah, so this is just rotating it by 90 degrees. So in my case I have to yeah, so I would have to do more in order to do this, but you don't have to, which is pretty lucky. Well, you shouldn't have to. I would be surprised if you had to. Because it's been a while since I played Mario Sunshine, if the left and right are also inverted, then you're going to want to, well, actually, that one's probably the rotation of Mario, so you're probably going to have to do the same thing that we just did with this, except you're going to have to rotate Mario the opposite direction. So you would hold left and it would be like, hey, let's go to the right instead of the left. So yeah. Anyways, so that has been this. Oh my goodness, that was so hard for me to figure out how to do that. Like it's really, this is really complicated. It should almost never be this complicated.